Hi everyone, glad to see you again. Today I have something informative lined up for you. If you found this video helpful, don't forget to like, share, and subscribe. Stay safe online, cyber network. Before we go any further, let's be crystal clear. This is serious business. What we are about to discuss is for education only. We're exposing a dangerous digital threat so you can defend against it. Using this knowledge to attack systems you don't own is illegal. Think of this as learning how a burglar picks a lock, so you can build a better one. SQL injection is one of the oldest and most effective digital traps. It's been used to steal data from massive companies and compromise millions of people. Understanding how it works is the first step to making the internet safer. This knowledge is a shield, not a sword. Your responsibility is to use it defensively, to protect your own projects and help others secure theirs. People trust websites with their names, addresses, and credit card numbers. An SQL injection attack shatters that trust. By learning the mechanics, you become a guardian of that trust. This guide is your training manual for defense. It's a look inside the mind of an attacker so you can anticipate and fortify. The information that follows is for learning, building, and protecting, not for malicious use. The consequences of misuse are real and severe. With that understanding, let's begin our journey. Let's step into the shadows to understand the threat. Let's learn how to build a more secure digital future. This is your chance to be a hero in the digital world. Let's get started. So what exactly is SQL injection? Let's break it down. Imagine a website asks for your username and puts it into a command written in SQL, the language websites use to talk to databases. Normally it just finds your info. But what if an attacker enters something like Grant or 111? The database now returns everything, not just one user. That's SQL injection, tricking a website's database into running commands it shouldn't. The attacker injects malicious code into a legitimate query, hijacking the conversation. Suddenly, they can access all the secrets the database holds: usernames, passwords, credit cards, company data. They can even change or delete information, all because the website trusted user input too much. It's a simple vulnerability with catastrophic consequences. Understanding this trick is key to defending against it. SQL injection is about exploiting trust between a website and its database. The results can be devastating. That's why it's so important to know how it works. Why do attackers use Python scripts for SQL injection? Manual testing is slow and leaves traces. Automation is faster, more precise, and much more dangerous. Python is easy to use and has libraries for everything. Attackers write scripts to do the boring work for them, testing thousands of pages and input fields in minutes. The script crawls a website, finds every form or parameter, and tries a list of SQL injection payloads. It analyzes responses for signs of vulnerability, errors, changes, or delays. This turns a slow, manual attack into a high-speed operation. One attacker can scan thousands of sites with terrifying efficiency. Automation is what makes SQL injection such a widespread threat. It's like having a robot army testing every door and window on the internet. That's why understanding automated attacks is so important for defenders. The scale and speed of automation change everything. Defending against scripts is much harder than defending against a single person. That's why we need strong, automated defenses too. Let's see how these scripts find their targets. The first job of a Python script is to scout for weak spots. It starts at the home page, reading HTML to find every link and page. It crawls the site, building a list of all pages to visit. But it's not just looking for links, it's hunting for user input. URL parameters like ID = 123 are prime targets. Forms, login, search, registration are all potential entry points. The script catalogs every parameter and form field it finds. It builds a complete map of where the website talks to its database. This mapping phase reveals dozens or hundreds of possible injection points. For a human, it's overwhelming. For a script, it's just a checklist. Systematic, exhaustive searching is the foundation of automated attacks. Without a good map, you're wandering in the dark. The script ensures no stone is left unturned. Once the map is ready, the real probing begins. The hunt is on. With its map of targets, the script starts probing for vulnerabilities. The classic test: add a single quote to a parameter. Does the site break? If an error appears, it's a red flag. The input is being used in an SQL query. Another test Boolean logic. The script tries ID equals sign 123 and 1 equals sign 1 should work, and ID equals sign 123 and 1 equals sign 2 should fail. If the page changes, the script knows it can control the query. Time-based tests are stealthier: inject and sleep 5, and see if the page slows down. If the site takes longer to respond, the script knows its code was executed. These techniques confirm vulnerabilities without obvious signs. The script can test hundreds of points in minutes, looking for any sign of weakness. Each positive result is a potential doorway into the database. The attacker now knows exactly where to strike. Probing is fast, systematic, and often invisible to defenders. That's why it's so effective. Once a vulnerability is found, the next step is extraction. The script is ready to dig for treasure. The real heist begins now. Let's see how attackers pull data from the database. Here's how the script extracts the goods. With a vulnerability confirmed, the script goes after the data. First, it figures out the database structure, table and column names, using clever queries. Union-based injection lets the script combine its own queries with the site's. It tests how many columns are in the original query, then uses union select to pull info from system tables. The script asks for a list of all table names, then all column names in interesting tables. Now it knows exactly where the valuable data is. It can request usernames, passwords, or anything else it wants. The database hands over the information, one row at a time. The attacker has the treasure map and the treasure. But some attackers want even more. For some attackers, stealing data isn't enough. They want total control. If the database has high privileges, the script can write data, change files, or even run commands on the server. The attacker might update the admin password, gaining full access to the website. They can deface the site, delete content, or attack visitors. Some databases let scripts create files on the server. The attacker writes a web shell, a tiny script that gives them remote control. Now, they can run any command, upload more tools, or attack other computers on the network. The initial SQL injection has become a complete system breach. This is the ultimate nightmare for any system administrator. A simple vulnerability exploited by automation can lead to total takeover. That's why strong defenses are critical. Let's talk about how to stop these attacks. Prevention is the only cure. Here's how you defend your digital world. How do we defend against SQL injection? The most important defense: use prepared statements with parameterized queries. This separates commands from data, so user input can't change the query. Even if an attacker tries to inject code, the database treats it as harmless text. This single step blocks most SQL injection attacks. Next, follow the principle of least privilege. The website's database account should have only the permissions it needs, nothing more. If an attacker gets in, their damage is limited. Always validate and sanitize user input. Check that inputs are the right type and format. Remove dangerous characters as a backup defense. Never trust user input, ever. Combine these strategies for a strong layered defense. Automated attacks require automated, robust protection. Make your application a hard target. We've explored how automated SQL injection works and how to stop it. This knowledge is powerful, but it comes with responsibility. The line between security research and crime is intent and ethics. Use this knowledge to build, not break. Protect, don't harm. Secure coding and limited privileges are now your tools. You're equipped to be a better developer and defender. Ethical hackers, white hats, use their skills to find and fix vulnerabilities. They make the internet safer for everyone. If you're fascinated by this, consider a career in cybersecurity. There's huge demand for defenders. The script we described is just a tool. It can build or destroy. The choice is yours. Use it to check your own work, educate others, and strengthen security. Never attack systems without explicit permission. The digital world is what we make it. Let's make it safe and secure. The responsibility starts with you. Be the hero, not the villain. Thanks for watching and learning with me. Drop a comment below if you have any questions or suggestions for future videos. I value your feedback. Cyber Network.